Last week or last class, we were talking about, or we got an introduction to quadratics. So let's talk about the cheat sheet for quadratics. And you know how important these cheat sheets are, because it'll allow us to kind of quantify everything that we need to know for every topic. So you should be doing a cheat sheet for every topic, right? And so for quadratics, one of the things on the cheat sheet is the general form y is equal to ax squared plus bx plus c. And you know a cannot be equal to 0, because that means that the x squared will be gone if a is 0. Right? If a is 0, then 0 times x squared is 0. So the whole x squared gone, and you'll just have this alone, which is not a quadratic. That alone is mx plus c. That's a straight line. Right? So the x squared is the important part here. Right? And a couple of things that we could remember. We could remember that a quadratic is a curve, and it looks like this. Right? But it only looks like this when a is positive. Right? When a is negative, it actually looks like this, where a is negative. And this is really super important, because you, just like how I could look at a line y is equal to negative 2x minus 3, and I could tell, well, okay, I could just look at that and I could know that that line is shaped like this, and it'll be cut in at negative 3. So just by looking at it, I have an idea of what the line looks like. Right? Same thing, you should be able to just look at this equation and have some idea as to what the curve will look like. Right? Now, it is important to know, you know, all of these things on the cheat sheet, by the way. Yeah? This is super important. Right? So then we found now that we could solve, to factorize, to solve for x. We had many different methods, right? The first method was to normal factorize, like say if I had x plus 3x, no, x squared plus 3x plus 5, for example. You know that I had to find two numbers that when I add them, right, I will get 3. But when I multiply them, I will get 5. Well, this might not be possible actually. Actually, you know, I just pulled this equation out of a hat. When I add them, I will get 6. Let me do this one. Yeah, this one is possible. Right? So that next one is impossible, right? And you'll see that I'll have 2. So when you factorize it, you'll get x plus something and x plus something. So you could see that, oh, this should be 6 here, and this should be 5 here. Right? When you add them, you'll get 5, and you multiply them, you'll get 6, right? So in this case, that'll be 2 and 3. Right? When you add them, you'll get 5. When you multiply them, you'll get 6. So you could see here that x is equal to negative 2 and x is equal to negative 3. So you see how I put this entire process on my cheat sheet. Just as a reminder, yeah, just as a reminder as to how to factorize, right? We saw a separate way to factorize when ax squared plus bx plus c, and I'll just do the general term for this, where when a is greater than 1, right? So in this case, a was just 1. But when a is greater than 1, we want to find two numbers that when you add them, you'll get b. But when you multiply them, you will get a times c. Right? And then we also saw the third method, which is my favorite method, which just, it doesn't factorize, but it just gives you the final answer, which is the values for x, the solutions, right? And those solutions come from where it was minus b plus or minus the square root of b squared minus 4ac all over, no, not that, all over 2a. So that was the third method. And then the fourth method we saw was completing the square. Which means that we had to take ax squared plus bx plus c and put it in the form a into x plus h squared plus k. And this is the form of completing the square. And can somebody remind me what is the formula for h? Anybody, quick.
H is b over 2a.
And what is the formula for k?
K is 4ac minus b squared all over 4a.
Thank you. Right? Now you see this here? Alright? Make sure you know this, because they like to ask it. And if you know these formulas, life gonna be easy for you. If you know these formulas, life going to be easy for you, right? So we will see for this class, this completing the square thing, we're going to be using this a lot in this class. So you'll get to know it a little bit more. Now, what are we doing when we factorize? When we factorize, we find in these two values are x, right? So remember, when we factorize, what we did was we take the x squared plus 5x plus 6 and we put it equal to 0. Yeah? We put it equal to 0 and then we factorize to get x plus 2 and x plus 3. And then we put each one equal to 0. X plus 2 is equal to 0, therefore x is negative 2. And x plus 3 is equal to 0, therefore x is negative 3. So what does this mean? These two x values here, these two x values are called the roots. And they are where, because you put the equation equal to 0. So an equation, when it equal to 0, what you're saying is y is 0. So that means when y is 0, that is the x-axis. Yeah? And what we can see here is that when we find the two values of x, the roots, what we actually doing is finding where the curve cuts the x-axis. It will cut the x-axis at y is equal to 0. So that is why we put y is equal to 0. So the whole thing is 0, right? So we could see that this thing will cut the axis at negative 2, negative 3. Yeah? We could see here that a is positive. So because a is positive means that this is going to be a curve like this. So that means it'll come like this. Right? And so we are able to sketch the curve just by factorizing it and looking at the a value. We're able to sketch the curve and have an idea as to what the curve looks like. Yeah. So let's just head up the first thing, sketching a curve. So we're gonna write this, right? Sketching a curve. And we're gonna use the same thing. Sketch y is equal to x squared plus 5x plus 6, right? Well, we know that for the roots, we'll put x squared plus 5x plus 6 equals to 0. That means we want it to be equal to the x-axis, and the x-axis is where y is 0. So we're making y 0, right? We could factorize x plus 2 and x plus 3 equals 0. Therefore, x is negative 2, x is negative 3. So we found the roots. That is where it cuts the x-axis. Right? So we have the little graph here. We found the roots where it cuts the x-axis, negative 2, negative 3. Right? And that is where it cuts the x-axis. That is when y is 0. But how do you think? Do you think that we could find out what is the point here where it cuts the y-axis? How do you think we could find out that? What we will call the y-intercept. So we have y equals x squared plus 5x plus 6. How can I find where it cuts the y-axis? It'll be C. Yes, it is C. It is that, right? And you remember that from the video, right?
Yeah.
Right. So you're absolutely right. But the answer that I wanted is that when it cuts the y-axis, that is when the x value is 0. So if you want to find the x-intercept, the y-intercept where it cuts the y-axis, that is when x equals 0 implies y is equal to 0 squared plus 5 times 0 plus 6. So you'll see all we end up with is y is equal to 6. Yes, C. So we can see here that this is going to cut where it's 6, right? So now we have the roots of the equation, right? We have the where it cuts the y-axis, right? And A is positive, therefore we know it'll be shaped like this, right? And what we call this is a minimum, right? So you can see the minimum is where the turning point is at the bottom, right? So when A is positive, you have a minimum. When A is negative, it'll be shaped like this, and you'll have a maximum. Yeah. But in this case, A is, and we'll see the maximum minimum thing. So we know then, because A is positive, we know it's shaped like this, and it is shaped like this, you know? Because it could be shaped either way, right? So we know it's shaped like that. It'll have a minimum, and it cut in the y-axis at 6, it cut in the x-axis at 2 and 3, right? Now, this is how we sketch a quadratic curve. But sketching a curve and drawing a curve are two different things, and there are some things that we don't know. We do not know two things. Number one, we do not know this point here, which is the turning point. We do not know that point there, and we need to find that point. That's what we'll do in this class, to find the exact point that is the turning point, right? And the other thing that they like to ask for is this line here. This line that cuts the parabola in two is called the line of symmetry. So we do not know the line of symmetry. So we pretty much already know how to sketch most of the graph. And in this class, we'll just need to know the line of symmetry and how to get the turning point, and we'll be able to properly sketch a quadratic. So hopefully this class shouldn't be very long. Write down this here and let me know when you're done. Now, to factorize this gonna be hell, because we need to add two numbers that'll give us 3. And we need to multiply two numbers to give us 5. But 5 is a prime number. The only thing you can multiply to get 5 would be 5 and 1. And 5 and 1 certainly not going to give you 3. So, when I am met with these crazy pieces of madness here, I like to use my quadratic formula. X is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. I want you guys to use the quadratic formula, and remember what the quadratic formula giving you is. You're supposed to get two values for x, and those two values for x are where the curve cuts the x-axis. So I want you guys to use the quadratic formula and solve for this equation and tell me what are the roots of this equation using the quadratic formula, right? I'll give you 2 minutes, just tell me when you're done. Something wrong or what? Any funny business happening?
You have to find the square root of negative 11.
Oh, and that's not possible, is it?
I don't think so.
No, you cannot have the square root of it. Well, let me check and see in case you're doing something wrong, right? So x is minus b, which is minus 3. I put in b in brackets, so I know that that inside there in the brackets, that is b, and I put in the minus there. Plus or minus the square root of b squared minus 4, a is 1, c is 5, all over 2 by a, which is 1. So x is equal to negative 3 plus or minus the square root of 9 minus 20 all over 2. So therefore x is equal to negative 3 plus or minus the square root of negative 11 over 2. Yes, this is not possible. This is not possible. So if this is not possible, what does that tell you? Make a guess. The simplest answer. No, it is a curve. Obviously, it's a quadratic equation. But it is actually not touching the x-axis. And? Makes sense?
Yeah.
Right? So it's not touching the x-axis. And if it's not touching the x-axis, that means that you wouldn't have any x-intercepts. So that means when you try to solve the equation, you're not going to get any values for x. You're going to get, Whoa. So in this case, we have no solutions. Or in other words, no roots. Right? So therefore, we have this other topic, the roots of a quadratic, right? And if this is the x-axis, a normal parabolic curve would have two roots. However, we can have a situation where the curve, the turning point of the curve just touching the x-axis. So we have one root. And then, like what you just saw, we have a situation here now where the curve not even touching the x-axis. So we have 0 roots. So give this a quick write down, tell me when you're done it. You guys have, I hope you have your graph paper with you. Alright. What we're going to talk about is drawing a quadratic equation. And what I want you guys to do is actually draw this equation. So complete the table and draw the quadratic equation. equation. Well, good for you that the table has already been completed. So yay, right? This is the quadratic equation here. Y is equal to x squared minus 2x minus 3. We could see that A is positive, so we can expect to have a minimum turning point, right? So I want you guys to actually, if you have your graph paper, use the full graph paper like this to draw your axis. Right? You can see here that the x-axis -3 to 5. So on the x-axis, you want to go from -3 here, and you want to reach up to 5 on this side, right? And then on the y-axis, we can see 12 is the highest number on the y-axis, and maybe -4 is the lowest number. So you want to make sure you can reach 12. You want to make sure you can reach -4. So inside of this area, you should be able to get your graph. Now we know that if you want to draw a straight line, right? If you want to draw a straight line, all you need is 2 points and you draw your line and life is happy. But a curve don't work so. A curve, you can't just draw a curve with 2 points. No, you need many points. And the more points you have, the better, because the more accurate you'll get your curve. So the more points you have, the better. So they're telling you here that they want you to completely draw this quadratic, and they give you this domain from x is -3 to x is 5. So what I did was I plug in x is -3 in here, and the answer that I got is 12. So when x is -3, y is 12. When x, so I have that point here. When x is -2, y is 5. So I have that point here. When x is -1, y is 0. So I have that point here. Right? No, I have that point here. Right? When x is 0, y is -3. So I have that point here. Right? So I want you guys have a whole bunch of points here. I want you to draw, not sketch. You're actually gonna plot each one of these points, and you're going to draw the curve as carefully as possible. And when you do draw that curve, look on your graph and tell me 2 things. I want you to tell me what are the roots of the equation. Of course, you're not going to factorize it or nothing, eh? You're not going to use the quadratic equation. You're going to look on your graph and tell me what are the roots and what is the turning point. Everybody understand? Right. Now I'm gonna give you a good 10 minutes to do this, but see if you could do it quicker than 10 minutes. The quicker we could do it, the better. So I'll give you a little 10 minutes, no more than 10 minutes, but if you finish before, just say done it. And let me know what you got for the roots and for the turning point. I want 3 answers. So what did you guys get for the roots and the turning point? We'll see if you all get the same things, right? So 10 minutes.
So
Uh-huh.
okay, so just basically plotting these points on the graph page.
Pretty much, yes. Now, at the end of the day, please remember that, yeah, you're plotting the points on the graph and you're playing dot to dot. So if this is the graph here, you know, we have -3 on this side, we have 5 on this side, we have 12 all the way up here. So the first point is -3, 12, so that'll be somewhere here. Right? The next point is -2, 5. So -2 and 5 will be somewhere here. -1, 0 will be here. Right? 0, -3 might be somewhere here. You know? 1, -4 gonna be here. You know, going up the road now, and then you connect, and you should get something like that. And tell me what the roots are, what the turning point is, right? Now, I do all of the work for you, eh? Normally, a question would I just give you this. So look at this. The question is, they give you this quadratic equation and they give you this domain where x is between -3 and 5. And they tell you to not sketch, draw. Right? That is the difference. So when they tell you to draw, you had to do a table, do up a set of points. So I take all of the values of x between -3 and 5. So -3, -2, -1, 0, 1, 2, 3, 4, 5. And I plug each one of them in the equation and I found what is the y value. And now we're going to sketch it. So I saved you guys half of the work, right? But it's important that you guys know, so you all understand how to come up with the table. All right, good. So I'll do most of the work for all you. So spend a little 10 minutes or even less, play dot to dot, and see what the graph looks like and tells me where's the root and the turning point. I'll give all you 5 minutes actually, and I'll check all you in 5 and see how all they do. Right, so you had about 10 minutes, well, a little less than 10 minutes. Anybody got anything?
Wait, for the roots, is one number or one?
It's two numbers. The roots is the two places that cut on the x-axis. Those are the roots of the equation.
Oh, that's the root. I'll put it as a one. The root side -1.
-1 and 3. Those are the two x values, right?
Yeah.
Right, and what is the turning point? Well, the turning point will be a coordinate there, because if it turns in there, it'll be a coordinate that'll have an x and a y.
It was 1 and
Right, so 1 on the x or -1? 1.
Yeah.
1 and -4 is the turning point. So that means this point is the turning point here. Shazay, Caitlin, you all got anything else?
I don't know.
Alright, good. So this is the graph here, and we can definitely see that it is cutting at -1 and 3. Right? We could definitely see that it cut in the y-axis at 3, and remember where it cut in the y-axis is where at -3, where it cuts the y-axis is where x is equal to 0. So we can see it here, when x is 0, y is -3, so that's where it cut in, and then we can see the turning point there, 1, -4, right? Now
I just had a question.
No.
How
Alright, yeah, wait it.
how you just get y values in the table?
Right, that's what I was asking you just now, right? So they gave you the x values that you're working with.
Yeah.
Right? They say use x values and use integers, so don't be using half and a quarter and thing. Yeah, just use integers, and from -3 to 5. So that is where I got these x values, right?
Yeah.
Right. So if I want to find the y when x is -3, right? Then I take -3 and I put it in my equation there.
Wait, so in a real life question, you would have to do an equation to find every point for y?
For every point, you're gonna have to plug in the x value to find what y is for that point.
Okay.
Yes. So therefore, let me just see, x is -3, so that means that -3 and -3 here. So -3 squared is 9. That's +9, right? And this here is -2 times -3 is +6, and -3, and that should give you 12, right? Right? 9 plus 3 is 12, right? So you understand, Shazay?
Yes, sir.
All right. So every x point we take and we plug into the equation to find the corresponding y point, right? Or coordinate. And we get this. Now, the gradient of a quadratic. I want to talk about this, right? Gradient, right? And don't write anything yet. Just watch for now, right? When we have a straight line, right? we know y equals mx plus c, and m is the gradient, right? We know that. And we just get m by this formula, y2 minus y1 over x2 minus x1, right? And let me just say these are the axes here, and that is the line that we do, right? When we have the 2 points, x2, y2 over here, and x1, y1 over here, what we're doing is we're taking the y values, y2 over y1. So that is the horizontal distance, y2 over y1. That is this horizontal difference here, right? And we're dividing it by x2 minus x1, which is this vertical difference here, right? So when we finding gradient, what we actually doing is we finding the horizontal difference over the vertical difference. Wait, did I do that right? No, sorry. It's the vertical is the y, right? So the vertical over the horizontal difference. That is what we actually do to find the gradient, yeah? The thing is that the gradient for a line is the same for the whole line. The entire line will have the same gradient. But if you look here now, when we're talking about a curve, it will have no m for a curve. Because a curve, the gradient changing constantly. And we could see the gradient of each part of the curve by drawing a tangent. So let me just say this point, for example. I could draw a tangent and see that, well, that is how steep that line there, which is a tangent to the curve at that point. That line, that is how steep the curve is at that point only. If I draw a point here and say, let me draw a tangent, the tangent at that point only gonna look like this. If the curve was touching, the tangent touching the curve at that point only. And let me just say, if I wanted to draw a tangent at the turning point, you can see the gradient at the turning point is flat. No gradient. Yeah, the turning point has no gradient. The turning point is always flat. Whether it's a minimum or a maximum, the tangent at the turning point will always be flat. So that have no gradient. But you could see here that this tangent is steeper than this one. So you could see here that the curve, the gradient of the curve is always changing, and that is the bottom line. So you could never find the gradient of a curve, because the gradient of a curve is always changing. But what we can do is find the gradient of the tangent at any point. So we could find the gradient of the tangent at any point, and that is what? That is this formula here. The vertical rise, which is essentially y2 minus y1, all over the horizontal shift, which is x2 minus x1. But you don't have any coordinates. So what are you going to do? Let me just say we wanted to find what is the gradient of the curve at the point where x is equal to 2. Well, where x is equal to 2, that is that point there. So you now gonna have to take your ruler and carefully draw a tangent, right? And then, now that you draw a tangent, you have to find the gradient of the tangent. And that will tell you what is the gradient of the curve at that point. And how Can you find the gradient of the tangent? Well, you could just take any triangle you want. You could just take, let me just say, this triangle here. You could just form a triangle and look at the vertical rise. That is 1, 2, 3, 4, 5, 6. Over the horizontal shift, that is 1, 2, 3. So therefore 6 divided by 3 is 2. So the gradient of the curve at the point where x is 2 is 2. So everybody understands how to find the gradient of a curve at a point?
Yes, sir.
Alright, well good. So that's what you're gonna have to do now. Right? That curve that you draw there, I want you to find the gradient of the curve when x is 2. So at the point where x is 2, you take your ruler and you draw your tangent. Because the answer I gave you here just now wasn't correct because, you know, I draw in freehand, so I'm not very accurate. So use your ruler, draw your tangent. You could draw it as long as you want, right? And remember, when you find this gradient, this is not going to be the exact gradient. This is just going to be an estimate. So that is why a lot of questions will tell you to estimate the gradient, because it wouldn't be exact, right? And each one of you should get a different answer depending on how slant you draw your tangent. So you draw your tangent and try to make sure that it only touching the curve at that point when x is 2. So I'm gonna give you 2 minutes to do that. Draw the tangent at the point where x is 2, measure a horizontal shift and a vertical shift, vertical rise, and see if you could find the gradient.
Like you said, when x is 2?
When x is 2, so that when x is 2, if you look on the graph here, when x is 2, that will be this point over here. And
I actually got 2 as well.
You got 2, okay.
Yeah.
Alright. So I'm just waiting on donuts from Caitlin and Scotia. That estimate will depend on how you draw your tangent. So I expect you guys would get slightly different answers, which is just fine, right? When I did it, I got 1.75. I got 3.5 for my vertical rise, right? And I mean, you could have used any, you see how I cut my triangle like this? I could have cut the triangle like this, or I could have cut it like this, you know? So it's really up to you how you cut that triangle, and you should get the same answer anyway. Nice. So, do you guys understand? So far, we know how to sketch a quadratic. Now we see how we draw a quadratic, right? And from drawing the quadratic, it's easy to see what the turning point is, right? It's easy to find a gradient using a tangent. We could find the roots. We could even see what the line of symmetry is. Anybody could give me the equation of this dotted line here? What is the equation of this dotted line here? Yep, it's x is equal to 1. You understand, Shizzy?
Yeah.
Yeah. So you can see that we could, when we draw a quadratic and we draw it properly, we could easily just look at it and see what is the line of symmetry. The line of symmetry passes through the turning point and it cuts the entire curve in 2. Right? So now we're just gonna talk a little bit about it. We have a couple of questions here, which is the same thing in terms of using the table, right? So take a screenshot of this and we'll take a look at this on Tuesday. We pretty much know what we're about to do now in terms of sketching. We pretty much know how to do it, you know? We know that when we sketch in a quadratic equation, what we just did there, you factorize it in order to find the roots, that is if it have roots, right? You plug x is equal to 0, or you could take the c value in order to find the y-intercept. You look at a to tell whether it's a minimum or a maximum. Okay? And Boom, you do that, right? But we saw that it have two things that we did not cover. We don't know how to find the turning point when we sketching. We could find the turning point when we draw it because we have a whole long list of points. But nobody had time to write out a whole long list of points and play dot to dot, right? So when we sketching, we need to find out how to find the turning point and how to find the line of symmetry, right? So we have this first note here, sketching quadratics. The quadratic equation of the form ax squared plus bx plus c represents a parabolic shape like this, and that is the turning point, and that is the line of symmetry. You all think you need to write this down, or everybody cool with this? So you might want to write down this one. Number one, determine whether it's a maximum or minimum. No, you might not need to write down this one, right? But if A is positive, then you're dealing with a minimum point. We talked about that already. And if A is negative, and you can see it over here, A is negative, so we're dealing with a maximum point. And how I like to remember it is A is positive, so it'll look like a smile. Right? Positive is a smile, negative is a frown. So do you guys think you need to write this down, or are you all good with this? Okay, nice. So when we sketch in a quadratic, we know a quadratic is a parabolic curve. The first thing we'll do is take a look at the A value. If it's positive or negative, we'll know how the curve looking, whether it's a minimum or a maximum. So the second thing is we'll find the turning point. And this is how you find the turning point. We will need to complete the square. So once you take the quadratic equation and you put it in the form A into x plus h squared plus k, the turning point is actually minus hk. So if you want to find the turning point, you find h, which is b over 2a, and you find k, which is that, right? And then whatever you find, like let me just say you find h is, let me just say that when you find h end up being 3 and k end up being 4, well then the turning point will be minus h minus 3 and then 4, right? So you can see that in order to find the turning point, we definitely need to complete the square, put it in the form of completing the square, and therefore finding h and finding k. It has some questions that will actually give it to you. Like it had a question where they tell you that a quadratic equation was x plus 3 squared minus 2. And you could tell that they gave it to you in the form of completing the square, where a is 1, h is 3, k is negative 2. And so you didn't have to do any kind of big thing. You could have just say, well, alright, h is 3, so negative 3, negative h, and k is negative 2, and that is your turning point there. So some questions, if the examiner is a good guy, then he'll probably give it to you in the form of completing the square. However, if not, then you need to complete the square to find h and k, and that will be your turning point, right? So let me know when you're done it. Write this down. This you definitely had alright. Now remember this f of x thing. This f of x thing is just another way of saying y. Yeah? And we actually, in the next topic, we actually going to be talking a lot more about this f of x thing. But wherever you see f of x, just pretend that it's y. So over here, this coordinate x, f of x, is the same as saying xy. So that's easy enough, and we already know how to find the roots, right? But now we're going to talk about number 3, the line of symmetry. And the line of symmetry is just simply minus h. That is all. Right? If you want to find that line of symmetry, and you'll notice that that minus h, that is the x value of the turning point, isn't it? We saw up here, all the way up here, that look, the turning point here is 1, negative 4, right? And whatever the x value is, what the x value is 1. So this is 1, negative 4. You can see that the x value is 1. So that x value is minus h. So I'm guessing that h probably ended up being negative 1. So when we plug it into minus h, it ends up being 1. Right? That is the turning point. And whatever the x value is, x is equal to 1. That is your line of symmetry. Right? So we could see here that when we find our turning point, right? The turning point minus hk, that x is equal to minus h, that is the line of symmetry. Right? So we could use the h formula to find it. Right? We have the turning point here. So you could just write this note and let me know when you're done. Right? And of course, finding the roots. I don't know if you all want to write this down, but it's just simply a matter of factorizing to find the roots. Yeah, so I don't think we need to write that down, right? The roots are where it cuts the x-axis. And right, so this is sort of a summary that we could talk about here just now. Oh yeah, all right, yeah. And then the y-intercept is when x is 0. So I plug x is equal to 0 in order to find y, which normally ends up being this c value over here, right? So let me talk about some summaries here, because I know it might seem like a lot, but it's really not. So a summary of sketching quadratics, right? If this is a quadratic that we have here, what do we need? We need the roots, we need the y-intercept, we need the turning point, and we don't really need the line of symmetry, but it is actually for it. And the line of symmetry. So number 1, we need the roots, and you know that is to factorize. Number 2, we need the y-intercept, and you know that is when x sub x is equal to 0 in the equation, and you'll get what y is. Or you could just use the c value. Okay. Number 3, we need the turning point, which is negative hk, and you get that from the completing the square. And number 4, we need the line of symmetry, which we don't really need actually, but it is actually fair, and that is x is negative h. And this is a total summary of sketching a quadratic, right? So write this down and tell me when you're done. Now another thing, it have another way to find the roots of the equation. Remember, to find the roots of the equation, we had 4 different methods, and method 1 was factorizing, right? Method 2 was also factorizing if a is not 0. Method 3 was using the quadratic equation, but method 4 to find the roots was completing the square. So if you meet something that you can't factorize, guess what? To find the turning point, you had to complete the square anyway. So you could just complete the square, and boom, that will give you your turning point, and it will allow you to actually find the roots of the equation instead of factorize it. If it's something that you can't factorize, completing the square will give you your roots. Because remember, when you complete the square, you could solve for x. Yeah? So let me know when you finish this. I'm waiting. And you can see a is not equal to 1. So factorizing might give you some problems. I would suggest that you find the roots by completing the square. Right? So you have this quadratic equation. Answer the question. Is it maximum or minimum? What is the turning point? State the line of symmetry. Find the roots. Find the y-intercept, and hence sketch the graph. I'll give you all 5 minutes. Should be good enough. The first thing I need to do is I'll just write out, putting it up the form. Wait, I have f of x is equal to 5x squared plus 30x plus 36. Is this a maximum or a minimum?
That's a minimum.
Minimum.
Yes, it's a minimum because a is positive, right? So the first thing I'll do before I even watch anything else is put it up the form a into x plus h squared plus k. I'll just come on this side. And what is h? The formula for h? B over 2a.
Yeah.
And the formula for k is 4ac minus b squared over 4a.
Yeah.
Alright, so now I'll just find my h and my k real quick. So h is b, which is 30, all over 2 times a, which is 5. So that is 30 divided by 10, which is 3. And k is 4ac, which is 36. Damn, that's a big number. Minus b 30 squared. So I got 30, I got square the 30 first and then do the minus, right? Divided by 4 into a, which is who? I wish I had a dependent calculator lady, but she just bail out on me all the time. 36 times 5 times 4 is 720 minus 30 times 30 is 900. So this is a negative number we look at. 5 4s are 20, right? So therefore k is 720 minus 900 is negative 180 divided by 20. So k is negative 9, right? So therefore, right, is of the form a into x plus h squared plus k implies a is 5, x plus h is 3 squared plus k is minus 9. Alright, so did you all get that for your completing the square?
Yes, sir.
Alright, good. So therefore the turning point is minus hk, which will be negative 3, and then normal k is negative 9. You all got that for the turning point?
Yes, sir.
Yes, sir.
Alright, and a line of symmetry, x is equal to negative h, which implies x equals negative 3, yeah?
Okay.
Right, so you see, once we find all of that, we could find everything. The only thing that we didn't find so far is the roots, right? So therefore, for the roots, we could actually use this to solve the equation. 5 into x plus 3 squared minus 9, we put that equal to 0, right? And just like if we was factorizing, right? 5 into x, well actually I could skip that. X plus 3 squared is equal to, taking the negative 9 and throwing across, I get plus 9. And then I take this 5 and I throw it across, I get divided by 5. Yeah? So x plus 3 squared is equal to 9 divided by 5. Right? So x plus 3 now is equal to 9 divided by 5, the square root of that. Yeah? And therefore x is equal to, I take the negative 3 and I throw it, I take the positive 3 and I throw it across, I get negative 3. So remember, a square root has a positive and negative answer. So you're going to be the positive and negative square root of 9 over 5 minus 3. So therefore, one answer will be the positive square root of 9 over 5 minus 3. And the other answer will be the negative square root of 9 over 5 minus 3. Right? So that is where, when you're using the completing the square, that is where you just get your two roots from. The square root has two answers, a negative and a positive. Scotia, do you understand this?
Yes, sir.
Alright, nice. So let's just see the square root of 9 over 5 is really 3 over root 5, you know, but I will see the square root. Where's the square root sign? Of 9 over 5. Oh, I get decimal and I don't want decimals, right? So because I don't want decimals mean that I could just say that this is the square root of 9 is 3 over root 5 minus 3. And then that's plus 3 over root 5 minus 3. And then this one will be negative 3 over root 5 minus 3. Right? And if you want, you could work out the decimals, you know, right? 3 divided by the root of 5 minus 3 is this one going to be negative 1.6. And this one just now minus this one. Negative 3 over the root of 5 equals, right, minus 3. This one here will be negative 4.3. Yeah. So yeah, we have some values here for the roots. So you can see here that for every single thing we basically use that completing the square form for. The completing the square, right? It gave us, when we found the h and the k, we were able to complete the square, and that gave us the turning point. It gave us the line of symmetry, and it gave us the roots, negative 1.6 and that. So now we can actually sketch the graph. And we'll see what the, well, actually, did we miss anything?
So I have a question.
Yeah.
When it came down, the square root part, and you said you didn't want it that small, so you could squeeze it over to square 5. How do you do that?
How I reach from here to here?
Yeah.
Right. So remember, and that's a good question, and that we actually did that already in the laws of indices, right? Because if I have the square root of 9 over 5, right, that is the same as saying the square root of 9 over the square root of 5. Now why? Why is that the same? Well, remember what the square root of 9 over 5 actually is. It's actually 9 over 5 to the power of a half. Yeah? And we know that if we have m over n, or alright, let me just say from the laws of indices, if we have a over b to the power of m, that is the same as a to the m over b to the m. Right? Remember this? Yeah? So at the end of the day, this is the same as 9 to the half all over 5 to the half. Does that answer your question?
Yes, sir.
Alright, so that is something from the laws of indices there. Just remember that whenever you have a square root, that is actually to the power of a half. Whenever you have a cube root, that is to the power of a third. Whenever you have a fifth root, that is to the power of a fifth. You understand? Right. So I actually, and really and truly, I'll tell you something, whenever you're doing maths, you want to avoid decimal places, especially these kind of graph questions. You really want to avoid decimal places. So that is why I went from this step to this step. I didn't really need to do this step. I could have just used my calculator and go from here straight to here. Yeah? I just took this extra step just to see if I could get an answer that would have avoided decimal places now. You know? I just wanted to see, but I saw that no, I can't avoid the decimal, so I had to go that way anyway. But you always generally want to avoid decimal places and keep your answers in fractions if you could, right? So, like if you was doing add maths, then they don't want this at all. They would have tell you leave it like this. Yeah, if you was doing add maths, right? Because this is actually a hell of a lot more accurate than this. Because remember, the decimal have 100 other decimal places after it. So these answers here are not accurate at all, right? So there is one thing that we missed out, and that is the y-intercept. So the y-intercept is when x is equal to 0. We could see here that the y-intercept is going to be 36, right? That is the c value here, 36, when x is 0, right? So that's easy enough. So we were able to get the maximum, minimum, turning point, symmetry, roots, y-intercept. Now sketch the graph. And to sketch the graph, it's probably, I just try to sketch it a little small over here. Right? I see that my roots are negative, so this is going to be a negative kind of thing. The roots here are negative 1.6. And then over here, negative 4.3. The turning point is negative 3 on the x, which is somewhere here, negative 3 on the x, and negative 9 on the y, which is all the way down here. So that is your turning point, negative 3, negative 9, right? And then all the way up here, 36 is the y-intercept, and so your graph going to look like this. Right? And I know that is not particularly the neatest thing possible, but just to understand. So does everybody understand, like Scotia and Shazia, how do you guys feel about this topic? Is it okay?
It's okay.
Yeah, it's okay.
Yeah, it's okay, right? And this concludes quadratics, right? So I have a couple of questions for you all here. Take a screenshot of this. So you go in your classwork, you go all the way down to Algebra 2, and in Algebra 2 we have the quadratics lesson here, and quadratics 1, quadratics 2, this is what we covered in the last 2 classes, and this is your quadratics worksheet. This is what I want you guys to do for the next class, and this is super important because this has all CSEC past paper questions. Just now let it load, right? So this first one here is just a simple sketching the point, same thing like what we just did. You have 3 easy equations, you can sketch them, right? No problem. But then this here is your CSEC questions, and let me take a look at this question here. You can see that the diagram shows y is equal to x squared plus 2x minus 3 for the domain x between negative 4 and 2. We could see here negative 4 here and 2 over here. I hope I'll see my mouse as well, right? So they say here, use the graph above to determine the scale used on the x-axis. Well, that's kind of dumb, right? 1 mark, I guess, right? The value of y when x is 1.5. Oh gosh. The value of the values of x for when y is 0. You know that is the roots, right? And the range or the number of values of y given that your answer in the form. So where's the range of y here? So take a gander at this one, see if you could figure it out, right? Then we have some of these questions that we're going to take a look at in terms of factorizing quadratic equations. Now there is something here. Look at the first question of each one of them. No, yeah, the first question in part D. This is a difference of 2 squares. We actually spoke about the difference of 2 squares in one of the earlier classes last year in September. this part 2 for this question 2 is also a difference of 2 squares. So see if you can remember what the difference of 2 squares is and factorize these things. And of course, this is where you have your factorizing. Look here, this is a factorizing question right here, right? In terms of a quadratic, right? So see if you could factorize these. This here is a number 9, so this is way down in the paper. So this is one of the harder questions. You can see here we have a simple quadratic here to factorize, and then we have a not so simple one to factorize, right? You have to expand. So this is more of a distributive law question here, to expand this equation. Over here, we're given this formula. We can see it's a quadratic. It's of the form ax squared plus bx plus c. They tell you to write it in this form, which is the complete in the square form. Then they tell you to state the equation of the axis of symmetry, or the line of symmetry. They tell you to state the coordinates of the minimum point. How kind they are to even tell us that it's a minimum point. And then they tell you to sketch the graph. So this is definitely one. And then on the graph, you have to show the minimum point and the axis of symmetry, right? Or the line of symmetry, right? So you could see here that all of these are from CSEC papers. You'll either get a number 9 to be a quadratics question like this, or a number 2 or 3 where you'll have to factorize like that. So that is generally your paper 2. Number 9 or around number 2 and 3 is where you'll have some quadratic work to do. This number 9 here, take a look at this. Solve the pair of simultaneous equations. And we have a simultaneous equation with quadratics. Now, when we did simultaneous equations before, you know, simultaneous equations have some different methods in it, right? And we basically bypassed some of the methods and we went straight to the method of substitution. And when we did simultaneous equations, we really focused on the method of substitution. And this is why you're going to have to use your method of substitution to work this out. So solve this pair of simultaneous equations and state, giving reason for your answer, whether this line is a tangent to this curve or not. Yeah? So I really want to see how you guys could tackle these questions here. Right? This is another kind of number 3 factorizing question here, where you just factorize different questions, different stuff here. This is a number 6. Ooh, we see, and this is a real interesting one. Right? This here, it uses a quadratic, and it looks like a quadratic equation question, but it's actually not a quadratic equation question. This is actually a coordinate geometry question, but it's disguised as a quadratic equation question, right? So that is why I gave it to you all, right? Nice, and that is it. It's only like 6 slides. So that is 6 questions really. So we are going to be taking a look at this. This worksheet covers everything that we did in quadratics. So if you don't want to do the screenshot questions, you don't have time to do that, no problem. But you have to do this for next class. Next class, we'll be taking a look at these questions. And if you can handle these questions, then you should be able to handle any quadratic question that they throw at you, right?